this video, for the first time, we will be using mesh analysis to analyze a circuit that contains a current source. Quite difficult to write a KVL equation in a loop that contains a current source, but there is a way to approach this problem. So the first thing we want to do when using mesh analysis is we want to identify our meshes, and let's make this our first mesh, second mesh, and third mesh. So the next thing we do is we assign current to each mesh. So if this is our mesh 1, I'll call that current I1. This would be mesh 2, and the current in it would be I2, and this would be mesh 3, and the current in it would be I3. So the next thing we do is that we proceed to writing the KVL equation in each mesh. So in mesh 1, okay, we start from A, and we have current I1 flowing through the 3 ohm resistor, but it is being opposed by current I3. So we would have 3 into I1 minus I3. Okay, then this current source, we do not know the voltage drop across it, so we are going to give it positive, negative, then we're going to give it a voltage. So we're going to say plus V, then we reach A, and this would be plus 6I1 minus 100 all equals 0. Okay, then from this we can say that V is equals to 100 minus 3 into I1 minus I3 plus 6I1. Oh, sorry, minus 6I1. We can then simplify this further, and we would say that V is equals to 100 minus that would be 9 minus 9I1 plus 3I3. Okay, let's call this our first equation. Then we can proceed to mesh 2. And then in mesh 2, starting from here, we have say mesh 2. So we come here, we have 2i2, then plus 50 volts plus 50, then this would be 2i2 minus I3. We also have I3 opposing the current flowing through I2, then plus 50, then plus 4I2, then we have minus V equals 0. Okay, we can then simplify this further, and then we would say that 6i2, okay, minus 2i3 minus V equals minus 50. Let's call this our second equation. Then one thing I want to call your attention to is the relationship between this current source and these two mesh currents. You see, this current I2 is flowing the direction of the current source, and current I3 is flowing opposite. And we can use the relationship between them to we can use the relationship between them to determine the current flowing in this branch. And the current flowing in this branch, as you already know, is 5 amperes. So if this current is aiding the current source and this current is opposing it, then we can say that I2 minus I1 is equal to 5 amperes. So we say I2 minus I1 equals 5. Then we can call this our third equation. Okay, then we can go ahead and substitute this equation 1 into equation 2. Okay, then if we do that, we would have 6I2 minus 2I3 minus 100 plus 9I1 minus 3I3 equals minus 50. Okay, we can then simplify this further, and we would have I2. Okay, we would have 9I1, okay, plus 6I2 minus 5I3 equals 50. Let's call this the fourth equation. Then the next thing we want to do is that we want to write the KVL equation for the third mesh. So in mesh 3, so we start from here. I have 10I3, then we have 2I3 minus I2. Then we would have plus 3 into I3 minus I1. Then we equate it all to 0. You can then simplify this further, and we would have that's 12, 15I3 minus 2I2 minus 3I1, all equals 0. And we can call this the fifth and the last equation. We can solve equation 3, 4, and 5 simultaneously, and we would arrive at our values of I1, I2, and I3. This, the value of I1 would be equals to 1.75 amperes. The value of I2 would be equals to 6.75 amperes, and the value of I3 would be equals to 1.25 amperes. Thank you for watching the video. Don't forget to hit the like button and subscribe. See you later. Bye.